Hello friends, welcome to C# Intermediate to Advanced tutorial. You are watching C# threading subseries 1. Here we will look at single threaded UI. So what is meant by single threaded UI? That's what we are going to see here. Form UI actions bound to a single thread. So we call that as a UI thread. Once again, form UI actions are bound to a single thread. So in the last video, we learned about the basics of process and thread, how OS can tackle multiple processes, and how process can span multiple threads, and how CPU time slicing mimic parallel execution instruction set. When you create Windows Forms application, by default all UI actions are bound to one thread. By default, UI actions are bound to one thread. That means there is one thread that responds to the UI actions. Let's say one of the UI action, a button click, is starting a long task, a 30-second task. Then your user cannot interact with the form for that 30 seconds. Why? Because a button is clicked and that button performs a long running task. So for 30 seconds the form becomes unresponsive. So when user clicks some other button, nothing happens. So we will create a simple demo to experiment this behavior. Here, if you see, we have a form, and the generate number button will generate some random numbers or a running count. We will decide that when we go to the demo, and it prints those numbers to the console output window, or we can even write it in the debug output window, since we are creating it as a Windows based project. Then we will talk about generate number threaded behavior later. Here there is one more button, and when you click this button, say hi, the message will be printed in the debug console stating hi or something, some greeting message. Now let's look at this. First, we are including system.diagnostics. Why? Because we want to access the debug output window and write something. Then btn gen numbers. This is the one. And click event handler. We named this button as a btn gen numbers, and when user clicks that button, we are simply making call to a function task. So this task will generate 16,000 random numbers and prints that in the debug output window. So here is the task function. If you see, debug.writeLine, starting the task. Then we make use of the random class, and we named it as a RAND. We are starting a loop that runs for 16,000 time. Inside the loop, we are asking RND. This is our random number, right? Next 16,000. That means the random number will get generated, and it gives a value between 0 to 16,000. 0 to 16,000, and that will get printed on the console output window. Count I, then some random number that will get printed in the debug output window. After finishing this, we are printing a message task ends. Alright, so we know the message will go like this: starting task A, ending task B, and in the console output window you will be seeing A, then after some point in time you will see B. Alright, so this is one sequence. And next, if you see in the btn high, we access the same debug output window and we print a message stating hi from button click. So if you see here, let's assume this is a long running task or work 1, and this is some other work 2. Work 1 is printing the random number, work 2 is printing a hi from button click, some message, right? So this is a Windows form and we call this as a UI thread. There will be one thread and that's called UI thread. If you see here, once you click generate random numbers, here there is only one instruction set, but the loop will run for 16,000 times. So CPU will execute same instruction set for 16,000 times. Since this is in a loop, and if you unfold this loop, there will be 16,000 instruction set, right? So all will get executed and CPU will be busy. Say for example, if it takes 10 seconds, so the UI will be unresponsive for this 10 seconds. Let's say we have work 2, there are some instructions set to print this message. Now when work 1 is going on, work 2 will wait. So let's say user clicked this generate number and user clicked this say hi also. There will be some message pumping, and what happens, application, there is something called application will deliver the UI events to the farm, and the farm is already busy and there is only one UI thread, so the thread is busy executing some task. So from application, the message will not get delivered to this UI, or it will not get processed. The same at present in the current situation, this is the time slice, and let's say UI action, you clicked the generate number button and you clicked the say hi also here. Of course the thread started because you clicked the generate number button, and here you clicked the say hi also. But what happens, the execution will still go even though it happened before. Nothing will happen. This will execute all the instruction set of A, and let's say this is instruction set for B. Once it is finished, even though this event happened a long back at this time, since the UI thread is busy performing the task A, we have to wait. So once this task is done, then the instruction set for task B will get executed. Why? Because there is only one thread, UI thread, right? So this is what happens. So in the console output window, if you see, you will be seeing the A and B. A is starting the thread, then instruction set, I mean the count number, that message. After that you will see B. Then you will be seeing the message for this after A and B, right? So if you click it 2 times, then you will be seeing 2 messages only after seeing the task end. Alright, now we will go to the demo and see how it works. So the form is available for you to download, and if you see, Our form is simple. We have a button and we named it as btn gen number. btn gen numbers, numbers threaded, then btn high. So let's generate the click event for the very first one, then we will create a click event for say hi as well. Since we need to use system.threading, here we are not going to use a thread. We need to study the behavior, and we don't want to span any thread, but we want to access the debug output window, so we will include system.diagnostics namespace. So next, in the btn numbers click, we will make a call to the task, generate method. Okay, we will generate the method task. We will delete this. So here we will be generating the random numbers. So random.random, then random.next will generate the random number. Finally, we will handle our btn high click as well. Now we will build the solution. We will make the output window available. We will clear this. So if you see, I'm going to click generate random numbers. Then before task finishes, I am going to click say hi 3 times. So click generate random number 1, 2, 3. Click the say hi 3 times. And if you see, I clicked say hi when the task is going on, and the message is not printed on the console window. So it is queued, and once a task finishes, then only the message, I clicked that button 3 times and it doesn't get printed in the console window. So it waited, right? Otherwise you will be seeing that hi from button click somewhere in between, right? There are all 16,000 message, and once it is finished, then the message from the button click is appearing. So this is the issue with single threaded UI. Say for example, let's generate the random number, and I am trying to move the form. So I already dragged it. See, once a task ends, it comes to the different location. Now let me clear this and click on generate random number, and immediately I will click this maximize button. See, there is a non-responding also here. Let's this time I will restore generate random number, and at some point in time you will see not responding. See, not responding, and there is a hourglass as well. So once the long running task ends, the OS becomes responsive, right? Alright, next we will, so we already wrote this task as a separate function. We will make this task as a parallel running task in the next video. That's all here in this video. Thank you for watching. Bye.